everybody, today we are going to speak about natural language processing, NLP. More particularly, I'm going to explain in 5 minutes how the Word2vec algorithm works. The main problem in NLP is to transform a series of words into a numerical vector, noted W, in RP. And Word2vec is going to enable such a transformation, usually called word embeddings. In the literature, the first attempt to deal with this issue tried to represent each word by a binary vector in the canonical basis. For example, let's consider man and men. The main problem with such a representation remains in the fact that no similarity can be computed between words. And the vector size representing each word is huge, since it is based on the number of different words in the considered corpus. More recently, co-occurrence matrices appeared. They enable to represent words in two large corpus of text, or build window-based observations matrices. The main idea of co-occurrent matrices is to represent each word according to its common neighbors. The context is therefore taken into account. For example, let's consider a very simple corpus of text made by 3 sentences. I like deep learning, I like NLP, I enjoy Algoflash. Here is the associated co-occurrence matrix. For each word, the common neighbors are computed according to fixed window size, and the size is fixed to 2 here. As we can see, each word is represented by a vector which is size equal to the size of the employed vocabulary in the corpus. Here, we can observe that a similarity can be computed between words. More particularly, if we compute the similarity, say the product scalar for example, between like and enjoy, we can expect a high similarity score. It's possible to reduce the dimensionality of such a matrix by using singular varied decomposition. Now let's speak about Word2vec algorithm. As previously, this algorithm uses the representation of words by its neighborhood, but this time the user chooses the dimension of data, noted P. According to the application, P can vary between 100 or so, or 1000. Now, the aim of Word2vec is to learn word vector representation that are good at predicting the nearby words. To do so, Word2vec is going to learn 2 vectors for each word. The objective function that the algo optimizes is the following. In other words, it computes the probability for each word to observe its context, its neighbors, given the observation of this word. W2 stands for the set of vectors describing each word of dimension 2 times the size of the vocabulary. In order to model the probability to observe a word neighbor given the current word, we can use the following model. Where theta and gamma stands for respectively the input and the output vector representation of each word. So, this objective function is optimized according to a gradient descent as it follows. By observing each word iteratively, we are going to learn theta of the current word and gamma of each of the words of the context by doing a stochastic gradient descent. In this example, the gradient computation is done according to linear algebra calculus, such as the computation time is reasonable. To conclude, Word2vec is a very nice and simple NLP algorithm which learns word embeddings by using context word. It creates a vector space between words. In such space, relationships between words are linear. We can illustrate very easily the meaning of these words, as it follows. However, for large corpus, Word2vec is quite slow compared to methods based on SVD which collect only once the corpus. Thanks guys for your attention.
If we are here not to do what you and I wanna do and go forever crazy with it, why the hell we are even here? There were never any good old days. They are today, they are tomorrow. It's a stupid thing we say, cursing tomorrow with sorrow.